Jabir ibn Hayyan, often known in the West as Jabir, was a prominent figure of the Islamic Golden Age. Born around 721 AD in the city of Tus in present-day Iran, Jabir's contributions to science and philosophy were monumental. His works were not only influential in the Islamic world, but also reached Europe, where they were translated into Latin and studied by medieval scholars. Flourishing between the 8th and 9th centuries, he is considered the father of chemistry. His extensive writings cover a wide range of subjects, including alchemy, medicine, astronomy, and philosophy. Jabir's approach to alchemy was methodical and experimental, setting him apart from his contemporaries who often relied on mystical and speculative methods. His groundbreaking work transcended alchemy, encompassing medicine, astronomy, and philosophy. Jabir wrote over 3,000 treatises, many of which detailed his experiments and observations. His works on alchemy, such as the Book of Stones and the Book of Balances, laid the foundation for modern chemistry. He introduced the experimental method to the field, emphasizing the importance of precise measurements and reproducibility. Jabir's rigorous experimental methods and systematic approach to knowledge transformed the field of chemistry. He was one of the first to use controlled experiments to test hypotheses, a practice that is now a cornerstone of scientific inquiry. His work on acids, alkalis, and chemical processes was revolutionary, and he is credited with the discovery of several chemical substances, including hydrochloric acid and nitric acid. His influence resonated far beyond his time, shaping the scientific landscape of both the East and the West. Jabir's works were translated into Latin and became standard texts in European universities during the Middle Ages. His ideas on the transmutation of metals and the philosopher's stone influenced alchemists for centuries. Moreover, his emphasis on empirical evidence and logical reasoning paved the way for the development of modern scientific methods. Jabir's legacy lies not just in his discoveries but in his pioneering spirit, emphasizing observation, experimentation, and logical deduction. He believed that knowledge should be based on evidence and that theories should be tested through experimentation. This approach was revolutionary at the time and has become a fundamental principle of modern science. This approach laid the groundwork for modern scientific methodology. Jabir ibn Hayyan's contributions to science and his innovative methods have left an indelible mark on the history of human knowledge. His work continues to inspire scientists and scholars around the world, reminding us of the importance of curiosity, experimentation, and the relentless pursuit of truth. Born in Tus, Persia, around 721 AD, Jabir's early life was steeped in knowledge. His father, a pharmacist, instilled in him a fascination with the natural world. This early exposure sparked Jabir's lifelong pursuit of understanding the properties of matter and their transformations. He received a well-rounded education, studying under renowned scholars in various disciplines. His education encompassed Islamic theology, Greek philosophy, and Persian alchemy. These diverse influences shaped his worldview and laid the foundation for his interdisciplinary approach to knowledge. Jabir ibn Hayyan revolutionized the study of matter by introducing a systematic and experimental approach. Unlike earlier alchemists who relied heavily on mysticism, Jabir emphasized observation, experimentation, and the importance of reproducibility. He believed that knowledge about the natural world could only be gained through meticulous experimentation. This rigorous approach marked a significant departure from the prevailing practices of his time, and laid the foundation for the scientific method. Jabir ibn Hayyan's laboratory was a testament to his pioneering spirit. He developed and refined numerous laboratory tools and techniques that became cornerstones of chemical practice. Among his inventions were the alembic, a device for distillation, and the retort, used for heating substances. He meticulously documented his experimental procedures, emphasizing the importance of accurate measurements and controlled conditions. This meticulousness ensured the reproducibility of his experiments, a key principle in modern scientific inquiry. Through his rigorous experimentation, Jabir made significant contributions to our understanding of chemical substances and processes. He is credited with the discovery of several acids, including sulfuric acid, hydrochloric acid, and nitric acid. These discoveries had profound implications for various industries, from textile production to metalwork. Jabir also developed new techniques for the preparation of metals, dyes, and glass. His work on the purification of metals, particularly gold, had a lasting impact on metallurgical practices. His contributions extended to the development of new inks, varnishes, and even waterproof fabrics. Section 6. A wealth of knowledge. Jabir's written legacy. Jabir ibn Hayyan was a prolific writer, and his vast body of work reflects his wide-ranging interests. He is credited with authoring hundreds of books and treatises on subjects ranging from cosmology and astrology to music and the theory of balance in nature. His most influential works focused on chemistry and alchemy. Among them are the Book of Chemistry and the Book of 70. These books provided detailed descriptions of chemical substances, experimental procedures, and alchemical theories. Section 7. Bridging East and West. Jabir's impact on European science. Jabir ibn Hayyan's work had a profound influence on the development of science in the West. His books were translated into Latin, the language of scholarship in medieval Europe, and widely circulated among European alchemists and scholars. His emphasis on experimentation and systematic observation resonated with European thinkers and contributed to the rise of experimental science. Figures like Roger Bacon and Albertus Magnus were deeply influenced by Jabir's work, integrating his ideas into their own scientific inquiries. Section 8. The mystical and the material. Jabir's philosophical underpinnings. While Jabir ibn Hayyan is celebrated for his empirical approach, his work was also deeply rooted in philosophical and mystical beliefs prevalent in his time. His contributions to alchemy and chemistry were not just about practical experiments, but were also influenced by the spiritual and metaphysical ideas that were widespread during the medieval Islamic Golden Age. Jabir's writings often reflect a synthesis of science and spirituality, where the quest for knowledge was seen as a path to understanding both the physical and the divine. He believed in the interconnectedness of all things and saw the material world as a reflection of divine principles. This belief in a cosmic unity was central to his philosophy. Jabir's concept of the balance in nature, where elements and compounds interact in harmony, was a precursor to later scientific theories about chemical reactions and equilibrium. His work suggested that by studying the natural world, one could uncover the hidden truths of the universe, bridging the gap between the seen and the unseen. This philosophical framework informed his alchemical pursuits, as he believed that by understanding the transformations of matter, one could gain insights into the secrets of the universe and the nature of creation. Jabir's experiments were meticulous and detailed, often described in his extensive writings. He documented various processes such as distillation, crystallization, and sublimation, which were not only practical techniques but also carried symbolic meanings. For Jabir, the transformation of base metals into noble ones was an allegory for the purification of the soul. His work represents a fascinating blend of rational inquiry and spiritual exploration. Jabir's legacy is a testament to the rich intellectual tradition of the Islamic world, where science and spirituality were not seen as opposing forces, but as complementary paths to wisdom. His influence extended beyond the realm of alchemy, impacting various fields such as medicine, astronomy, and philosophy. Today, Jabir ibn Hayyan is remembered not only as a pioneering scientist, but also as a thinker who sought to understand the deeper connections between the material and the mystical. Section 9. A legacy of inquiry. Jabir ibn Hayyan's enduring influence. Jabir ibn Hayyan's legacy extends far beyond his specific discoveries. He is often referred to as the father of early chemistry, a title that reflects his monumental contributions to the field. His work laid the foundation for modern chemistry and influenced countless scholars and scientists who came after him. He is remembered as a pioneering figure who transformed the study of matter from a mystical art into a rigorous science. His approach was revolutionary for his time, emphasizing the importance of empirical evidence and reproducibility in experiments. This shift from mysticism to science was a critical turning point in the history of scientific thought. His emphasis on observation, experimentation, and systematic documentation laid the groundwork for the scientific method. Jabir meticulously recorded his experiments and findings, ensuring that his work could be replicated and built upon by future generations. This practice of detailed documentation is a cornerstone of scientific research today. His contributions to chemistry, from the discovery of new substances to the development of laboratory techniques, had a lasting impact on various fields, including medicine, metallurgy, and material science. For instance, his work on acids and alkalis paved the way for advancements in industrial chemistry and pharmacology. Jabir ibn Hayyan's enduring legacy lies in his spirit of inquiry, his thirst for knowledge, and his unwavering belief in the power of human reason to unlock the secrets of the natural world. His influence can be seen in the way modern scientists approach their work, always questioning, always testing, and always seeking to understand the underlying principles of the universe. His life and work continue to inspire new generations of scientists and thinkers, reminding us of the importance of curiosity and the relentless pursuit of knowledge.